Hello everyone, my name is Birgit Hirschmugl. It's my pleasure to talk today about our recent collaborative publication in Allergy, in which we examine the impact of maternal-fetal omalizumab transfer on peanut-specific responses in an ex vivo placental perfusion model. The transport of maternal IgG across the placenta is mediated by the neonatal Fc receptor, or short FcRn, and is essential for passive immunization of the fetus. In vitro data demonstrated that anti-IgE antibody IgE immune complexes use FcRn-mediated routes, suggesting a mechanism for IgE transfer across the placenta. IgG-bound allergens can also cross the placenta, and it is important to understand the impact of omalizumab on allergen immune complex transfer, since omalizumab is one of the most frequently prescribed monoclonal antibodies to treat severe asthma in reproductive age. We report here the use of the ex vivo placental perfusion system, as you can see it here, and examine the impact of omalizumab on maternal to fetal transfer of peanut allergen and IgE across the placenta. When we determined RHA2 as a proxy for peanut protein in peanut extracts PE, we found peanut allergen already 5 minutes in the fetal circulation in our experiments, and the maximum concentration was reached after 90 minutes. Omalizumab was already detectable in the fetal compartment 15 minutes after starting the experiment and constantly increased over time, which is characteristic for maternal to fetal antibody transfer. To determine the transfer of allergen immune complexes across the placenta, we examined peanut extract transfer alone, as you can see it here in this panel, or in combination with plasma from peanut allergic individuals. Interestingly, when we had also omalizumab in our perfusion system, we found a twofold increase of transferred peanut allergen in the fetal compartment compared to PEPA alone. We were in particular interested in activation of basophils and if the transferred peanut allergen is capable to cross-link IgE on basophils, and therefore we performed basophil activation assays. And the transferred peanut proteins were fully capable of cross-linking IgE on the basophils in all our experimental conditions, which matched also the extent of transferred peanut allergens as we measured it before. However, we could not find any evidence for omalizumab-driven IgE transfer across the placenta, which was accessed via incubation of strict basophils with our perfusates. In conclusion, functional peanut allergen is actively transferred across the placenta, and this process might be enhanced by omalizumab. Active transfer of free IgE to the fetal site due to FcRn-mediated complex formation was not observed in our experiments. Our study calls for further investigation to better understand how allergen antibody complexes affect allergen-specific priming in the fetus with and without biological usage during pregnancy. With this, I want to thank you for your interest in our study and thank you for listening.